This particular question says that given a certain function, evaluate the first, the second, the third, and the fourth derivatives at the place where x equals 2. So obviously to be able to do that evaluation, I need to know what the derivatives are. So we're going to start there. Here is my first derivative, term by term using the power rule, 3 plus 3x squared. Here's my second derivative. Constant goes to 0, so I've just got this one, which is 6x. My third derivative, 6, and my fourth derivative, 0. And now to evaluate each of these at the place where x equals 2. So 3 plus 3 times 4. So 3 times 4 is 12, plus 3 is 15. F double dash of 2, so second derivative evaluated at the point 2. Here's my second derivative, where x is 2, I get 12. My third derivative is 6. It's independent of x, there's no x here, so it is just going to be 6. The derivative is 6, always. Same as this one, the fourth derivative is always 0, so it's always 0, regardless of what value this goes into. For this next question, we want to find the first, the second, the third and the fourth, and I'm going to use the calculator so you can see how to use that for this particular question. I'm just going to cover up our evaluations here for now. Just clear that out. Okay, so what we want to work out here is, so I'm going to go 2D. We want to use firstly we'll get the first derivative with respect to x of, careful of your brackets here, 2x minus 3 to the power 4. This is the first derivative, so I'm just going to write that down here. X minus 3 cubed. And then before I move on, I'm going to evaluate that at the point where x equals 2, because I need to know that answer anyway. So that is 2. We want where x equals 1 for this question. So it's minus 8. Okay, now the second derivative, so I'm going to show you where to find second and higher derivatives. 2D, calc, it's this one here. It's next to the first derivative function, it's this one here. We can type the little number in of the derivative that we're interested in, so in the second derivative, still with respect to x, of my original function, I can just copy that straight in, drag, then I can say go. It tells me that it's 48, 2x minus 3 squared. Also want to evaluate that at the point where x equals 1, 48. Now my third derivative, I'm going to be able to use exactly what I've done here, but now I'm just going to change that number to a 3. So the same function, and it'll give me the evaluation at the same time. So this is just being a little bit more effective, not having to type in the same question all the time. I get 192 times 2x minus 3. And as you can see there, it's already given me the answer of minus 192. Now my fourth derivative, again, all I need to do now is change this 3 to a 4. I get that it's 384, so therefore there's no x's in it, so it doesn't matter what this says, my fourth derivative is always going to be 384.